So the product rule, we use the product rule whenever two functions are multiplied. It's self-explanatory that product means product of two functions. So whenever you see any two functions which are multiplied, f of x is multiplied by g of x, then how do we differentiate product of two functions? And for the quotient rule, if two functions are divided, so like if you have f of x quotient of two functions, right? F of x over g of x. Okay? And Anika, when do you use the chain rule?
No, are you sharing your screen?
Oh my god. Wait, I wasn't
Sorry,
I was not sharing my screen and I was writing.
I wasn't sure, so I asked.
Yeah, I was not. Can you see it now?
Yes, now I can.
Okay. Okay, so I had just written this, that you will be using product rule when there is a product of two functions, so fx times gx, and we use quotient rule when there is quotient of two functions, like two functions are divided. Or if you see fractions, this is also called rational function. If you see any sort of rational function, then we will be using the quotient rule. And then Anika, when do you use the chain rule?
Um, isn't it like when there's both, sort of?
No.
Like when there's parentheses and power?
When there is parentheses and power, not really. We use chain rule whenever you see composition of two functions.
Okay.
Composition of two functions. For example, see, product and quotient is very easy to identify when you have to use product rule, when you have to use quotient rule. The chain rule, when you have to use it whenever you see composition. Composition means what? Composition is when there is one function as the input of the other function. So usually we have f of x, but instead of this x, you have another function as the input. So f of g of x. Okay? So instead
Okay.
of x, the input is another function. So this is called composition. So whenever you see one function inside other function, that means that is composition, and then you have to use the chain rule. For example, if you have a function like f of x is equal to square root of 4x plus 9. Why this is a composition? Your original function, now see, let me call this as h of x. Okay, now there was an original function f of x which was simple square root of x, and there was another function g of x which was a linear function 4x plus 9. Okay, and we
Okay.
we brought g of x inside f of x. So if you bring g of x inside f of x, so that means if you're doing f of g of x, so you are replacing x by 4x plus 9. That means you're replacing x by 4x plus 9. So this is the case of composition. Okay, and how do we differentiate the composite function. This is called now a composite function. Okay.
Okay.
So how do we differentiate such function? It's very simple. First, you will differentiate the like outer function. So first you will differentiate f, okay, and gx will be inside. And then you differentiate the inside function.
Okay.
Okay, so this will be the derivative of f of g of x. Okay, so if you have to find out derivative of this function, so Anika, what is the, so first you have to differentiate the square root function. Do you know what is the derivative of the square root function?
Won't I have to simplify it to like 4x plus 9 to the power of 1/2, and then like I can.
Yes, yes, you can do that. If you're comfortable with exponents, you can, you can write it as 4x plus 9 raised to 1/2. You can do it directly as well. So, okay, there are some derivatives that you should really know, that if you have a square root function, then its derivative is 1 over 2 root x. Like the derivative of a square root function in terms of square root. And if you want to do it like after you want to convert it into x raised to 1/2, and then you apply the power rule, then also you'll get the same answer. Okay, but
Okay.
if you know this directly, then you will save time.
Okay.
Okay, so okay, let's do it this way. So you have converted it into exponent. Then what will you do next?
I have to convert like each number, like find the derivative of each thing. So won't it be like, oh wait,
So now just think of this problem as finding out the derivative of x raised to 1/2. Okay?
so won't that be 1/2 x to the power of negative 1/2?
Yes, 1/2 times x raised to negative 1/2. And in place of x, you have 4x plus 9. Okay? So in your answer, replace x by 4x plus 9. That will be your this term. Okay? So this term is 1/2 times, instead of x, Anika, write g of x, because now you don't have x, you have g of x.
Okay.
So that becomes 4x plus 9 raised to negative 1/2. Okay, and then you multiply that by derivative of gx. So Anika, what will be the derivative of gx? Gx is 4x plus 9.
So gx is, wait, pause.
Gx,
So I have to find the derivative for x plus 9.
yes,
So that is 4. It wouldn't just be 4?
just 4, yes. So derivative of gx will be just 4. So you multiply that by whatever you got, you multiply that by derivative of gx, and this is your answer. Now you
Okay.
can simplify this. This is negative exponent, make it positive. This is 1/2 times. So how will you make it positive? This will go in the denominator. 4x plus 9 raised to 1/2 times 4. Now it's just algebra, pure algebra. And 1/2 is what? Square root. So 1 over 2 square root of 4x plus 9 times 4. So see, if you knew that derivative of square root is 1 over 2 root x, you could have directly written this answer 1 over 2 square root of, instead of x, we are doing 4x plus 9.
Okay.
And then multiply it by the derivative of the inside function, whatever is inside the square root. So that is 4. You can further simplify this. This becomes 2 times 2 is 4. So your final answer will be 2 over square root of 4x plus 9. Okay?
Okay.
Okay, so we are going to practice lot of questions based on this chain rule. Okay, let's take some questions in which you'll have to apply chain rule and also the quotient rule and also the product rule. For example,
Wait, Miss Vinda, can you go back really
yes,
quickly?
yes, sure.
Okay. Wait,
Hmm.
just to be clear in the algebra part, the reason why we move the 4x plus 9 to the power of negative 1 half down is because the exponent is negative. So that means it's becomes the denominator in order to be positive, right?
Yes, so here we are using the rule of exponents. So if you have something something is having negative exponent, if you want to make it positive, so you write it like this. You take the reciprocal of a, so 1 over a raised to m. This is the rule that we have used in this step. Okay?
Okay.
Okay. And I would recommend that you should know that derivative of square root of x is 1 over 2 root x. But if you don't want to memorize it, it's fine. You can first convert it in exponent and then simplify. Then when you simplify this will again become 1 over 2 root x, this expression. So you'll get the same thing. Okay, now so have you copied this down?
Yes.
Okay, now we'll do one problem. This is from your worksheet, problem number 9. Your function is y is equal to 1 half times x square times square root of 4 minus x square. Okay, so here you see actually you have three functions. This is the first function, this is the second function, this is the third function, and these three functions are multiplied together. Okay,
Okay.
now you don't worry about a constant function, this 1 half, just ignore it. Okay.
Okay.
Okay, so this 1 half will be there in your final answer, so you can just write y is equal to 1 half, okay, times x square times 4 minus x square. Or actually, let's apply the product rule. So Anika, do you remember the product rule?
Yes, so f prime of x times g of x times g prime of x times f of x.
Yes, so just remember, do not remember the formula, but remember the like what we have to do. So for example, if you have product of three functions, we find out the derivative of one function and we keep the other functions as it is. So like here when you have to find out y prime, we find out the derivative of 1 half, okay, derivative of 1 half, and we keep the other two functions as it is. Okay?
Okay. Just
And then you have to do this with all the functions. Then you do plus, then you find out the derivative of the second function, so derivative of x square, and you keep the other functions as it is. So times 1/2 times square root of 4 minus x square. Okay, so this is derivative of the first function, derivative of the second function, and then derivative of the third function. So you plus derivative of square root of 4 minus x square times the other two functions as it is. So 1/2 times x square. Is this step clear, Anika?
yeah.
So this is
So basically, I have to find the derivative for each term and like add it within like the full thing.
yes, this is your product rule. Whenever you have two functions or three functions or even four functions multiplied together,
Okay.
so you immediately apply the product rule. Whenever you see functions are multiplied. Okay, and now you can simplify these terms one by one. So Anika, what is the, you just have to find out the derivative of these three functions. So Anika, what is the derivative of half?
One. Wait. Sorry. Derivative 1/2. Is only. Won't it just be 0?
0. And derivative, in fact, derivative of any constant term, derivative of
Is
any,
always 0, right?
is always 0. Okay, so derivative of 1/2 will be 0. So this is 0. So 0 times whatever, this first term just becomes 0. Okay, 0 times this, 0 times anything becomes 0. Now we move to the second term. So 0 plus, what's the derivative of x square?
That becomes 2x.
2x. So second term is 2x times whatever you have, you write that as it is. Now come to the third term. Now here you'll have to apply the chain rule. When you have to find out derivative of square root of 4 minus x square, we apply the chain rule. Okay, so just how we did the previous question, this is composition of function, Anika. Can you see this
Right.
is
Yes,
composition?
yes.
F of x is square root function and g of x is a quadratic function.
Okay, so can't I just use the derivative rule that you told me to
Yes,
use?
first you find out the derivative of the outer function.
Okay, the outer function.
Outer function is square root function.
Okay. So isn't it just two? Wait, no, pause. I have to think of the answer. Won't it just be 4 minus x squared?
Wait, derivative of what?
The function inside is just 4 minus x squared because the power is just 1.
No, first you have to find out the derivative of the outer function. See, now this is actually composition of f of g of x. So you're right, then only you will get square root of 4 minus x square.
Oh,
So the outer function is f. This is your outer function. This is f. So what will be the derivative of square root x?
Well, wouldn't that be like square root? So it's just x to the power of 1/2.
No, 1/2
Oh,
times x
oh
to the
wait.
power of negative 1/2, right?
Yes.
Okay, but we don't have square root of x. We have square root of 4 minus x square. So you replace x by that. Okay, so this becomes 1/2.
Oh, okay.
Okay, you can also do this like this. If you have square root of 4 minus x square, so you can substitute this 4 minus x squared by another variable like y. So let 4 minus x squared is equal to y. Then this problem becomes square root of y. So its derivative becomes 1/2 times y raised to negative 1/2, and then you put the value of y back. So this is 1/2 times value of y was this, you put that back, 4 minus x square. Okay, this is another way of doing the derivative of a composite function. Okay, Anika?
Okay.
So this becomes 1/2 times, instead of x we had 4 minus x square raised to 1/2. Okay,
Okay. So basically for this, f of x will always be root of x, but and we just find the derivative of that and then plug whatever is inside it as x.
yes, and
Okay.
then you have to multiply it by derivative of the inside function. So then what's the derivative of gx?
The derivative of gx is would that be 8? Actually,
No, derivative of 4 minus x square will be
would that be 2x?
minus 2x.
Minus 2x, minus 2x, yeah.
Yes. So derivative of 4 minus x square will be minus 2x. Okay. So derivative of this whole thing, 4 minus x square, its derivative will be, you multiply these two functions. Okay. So 1/2 times 4 minus x square raised to negative 1/2 times, you multiply this. Okay, and then you
Okay.
can simplify the terms. This 2 and 2 gets cancelled, and you can make this exponent positive, so this becomes 1 over square root of 4 minus x square, because 1/2 power means square root, and this is x, so x is multiplied here. Okay, this is the derivative of this term. Okay, Anika?
Okay.
So you put it, you multiply it by the remaining terms, so we are getting x over square root of 4 minus x square times 1/2 times x square. Is this one clear, Anika? And so your
Yeah.
final answer will be, like, you add all of them. So your final answer is, you can do further simplification. This 2 and 2 gets cancelled, and this finally it becomes, so this 0 you can ignore, so x times square root of 4 minus x square plus, this is x times 1 times x square will be x cube over 2 times 4 minus x square. This will be the final answer. You can note it down.
Okay.
Have you noted it down?
Yes.
Anika, we have done only composition of like square root function. There can be composition of any two functions. You can take
Okay.
any two functions and you can take their
Also do like trig, like composition of trig functions.
yes. For example, I'm taking problem number 13, that is a composition of trig and logarithmic function. So the
Okay.
13th problem is where you have y is equal to tangent of ln x. So here, can you tell me what is f of x and what is g of x so that f of g of x becomes tangent of ln x? What should we take f of x? What should we take g of x?
Well, g of x is inside, so won't g
Right.
of x be ln x? And then
Yes.
f of x would be tan?
Tan x, yes.
Okay.
So f of x is tan x, g of x is ln x. So now how will you find out the derivative of this? First, you find out the derivative of outer function. So you will write your steps like this. So this will be, you will say that let f of x is tan x, let g of x is ln x, then f of gx becomes this, and then derivative of f of g of x. You have to write the chain rule. So then it is f prime of g of x times g prime x. So we find out the derivative of tan x. So Anika, what's the derivative of tan x? You should know,
Yeah, the
memorize of all trig functions.
right. So I think it's is it secant?
No, so Anika, first thing you should remember, you should memorize the derivative of all trig functions if you have a quiz tomorrow. So let's do one by one. What is the derivative of sine?
Cosine?
Cosine. What's the derivative of cosine?
Would that just be sine?
Derivative of cosine is negative cosine. I mean negative sine, sorry. Derivative of cosine is negative sine x. Okay? Think of it like this, that sine is a good function, cosine is a bad function. So cosine gives us a negative sign. Okay? Then we come to tangent. Derivative of tangent is, you were saying secant.
What is secant? Secant? Or is it secant squared?
Secant square.
Okay.
Okay. Okay. Then other trigonometric functions. Um, in some in some curriculums they only teach you about these three trigonometric functions. Let me see which functions you have. I think in your worksheets, no, you have cosecant as well, so you have to do all six. Okay. Then cosecant. Cosecant is, derivative of cosecant is minus cosecant x times cotangent x. Okay, Anika? This is,
Okay.
somehow you'll have to memorize them, and the more you practice, the more you'll be able to you'll able to memorize them. Then derivative of cotangent x is negative cosecant square x. Derivative of secant is secant of x times tangent of x. Okay, I think you know the derivatives of the first three function, right? First three
Yeah.
functions you have
Yes.
memorized. For the last three functions, how will you memorize this? So think of secant as tangent is secant square x. So secant is secant times tangent x. Secant times tangent. Okay? And
Okay.
similarly, cosecant, you see there is actually a relationship. Tangent and secant square x, and cotangent and cosecant square x. So tangent is a square, derivative of tangent is square of secant, and derivative of cotangent is square of cosecant but with a negative sign. Okay, then
Okay.
secant x is product of secant and tan. Cosecant is product of cosecant and cotangent but with a negative sign. Okay, I think I got a better way of making you memorize this. So, Anika, just put co in front of tangent. So, what do you get? Cotangent. Okay? And then put co in front of this. So, what do you get? Cosecant square. And put a negative sign. That's easy, right?
Yes.
Now you can
Okay.
remember this. Cotangent is written in short, it is written as cot. Okay? Now you will remember for cotangent.
Yes.
Okay. Then um, you should remember for secant. Just remember secant is secant of x times tangent of x. And then you put a co, so it becomes cosecant, and you put a co here as well, so it becomes cosecant times cotangent but with a negative sign. Okay, so just remember this one and put a co. Okay, Anika, now you'll
Okay.
remember them. Spend some more time, try to write the derivative column by yourself at least 3 to 4 times. Okay, now let's come to this question, Anika. So first you have to find out the derivative of the outer function. So what's the derivative of tangent?
The derivative of tangent is secant squared.
Secant square x. So we will write
Where
that secant square. But see here, you don't have to write secant square x, you have to write secant square gx.
g of x.
So secant square ln x. Okay, times derivative of gx. Gx is ln x. What's the derivative of logarithmic function? So you should also know that derivative of logarithmic function is 1 over x. Okay, Okay, Anika?
Okay. Okay.
And what's the derivative of exponential function?
That is that 0 or 1?
No, derivative of exponential function is exponential function. This is the only function
Oh,
in the
so it's
world.
the same. Okay.
Yes, this is the only function which whose derivative is same as the function.
That function. Okay.
Okay, so derivative of ln x, the function which is inside, that's 1 over x. So now this is your answer, secant square ln x over x. Okay?
Okay.
Okay, Anika, let's do some more problems. Now, this was still chain rule. I want to take a problem in which you have to do chain rule as well as product rule. Okay, we have one question. We have x times this. Okay, problem number 23. Your f of x is given by ln x cube cosine x. This is how the problem is given. Okay, so Anika, can you see here? Okay, what comes to your mind? What should you do here? What should be the first step?
Um. Okay, so the first step here, well, I know that f of x will be equal to inverse, right, like f,
Inverse.
like, wait, sorry, ln cosine x, because that's the outside, and then g of x will be equal to x cubed.
Uh, Here, this is actually product of two functions. See, this is
Oh, wait, so it's three function,
no,
or
no, no. This is
is it?
two functions. This is first function. This is composition, and this is another function. This is actually multiplied. So this dot
Oh,
is not given in the question. You will have to identify this by yourself by looking at the question. That this is actually the product of two functions. Okay, this
alright.
is your first function ln x cube, and this is the second function cosine of x. Okay, so that means our first step should be to use the product rule, right?
So, yeah, so derivative,
Hmm.
so L, the derivative of ln x cubed times cosine x, and then also ln x cubed times the derivative of cosine x.
Yes, perfect. So f prime x will be, we first find out the derivative of ln x cube, derivative of this, times cosine x plus, as you said, ln x cube times derivative of cosine x. Okay, now to find out the derivative of ln x cube, this one, here there is composition. Can you see this is composition of two functions?
Yes.
Okay, so what will be the derivative of ln x cube?
Okay. Mm. Okay, so if I let f of x be equal to ln x and then g of x equal to x cubed, is that
Right.
correct?
That's absolutely correct. And
Okay.
don't take fx as ln x because they have all in the question f of x is actually already taken for this whole function. So take any other
Oh,
function, for example,
h of x.
yeah, h of x, g of x.
Okay, so then f of x is equal to h of, no, is equal to, so that means h of g of x is equal um, to ln x cubed.
Yes, if h of x is ln x and g of x is x cube, then h of g of x is ln x cube,
Okay, and um,
and then you have to find out the derivative of this function,
okay.
this whole thing. So you use the chain rule.
So if I'm using the chain rule, that means so h of x.
No,
Wait,
h of gx.
yeah,
That's the only difference.
h1 of gx
Times, so derivative of the outer function,
times
derivative
just
of the
g of
inner function.
derivative of g of x.
And when you're doing derivative of outer function, then instead of x, you have to put the inner function.
Okay.
Mm.
So that means the derivative of g of x is equal to 3x.
3x square.
Oh, yeah, because you have to subtract. Yeah.
So that's this term. And what will be derivative of ln x cube?
Will it be ln 3x squared?
No,
Or is
no. So, just ignore whatever is inside. Just consider this as you're finding derivative of ln x, and then in your answer replace x by x cube. Okay,
okay.
all the
So
possible
that
terms.
means 1 over x.
1 over
But
x cube,
yeah.
because derivative of ln x is 1 over x, but you replace x by whatever you have, whatever you have here, you replace x by that, so this becomes 1 over x cube. And you can simplify this, 3x square over x cube,
X squared over x cubed.
3x square over x cube, which is 3 over x.
X, because you have to take down. Okay, yeah, that
Yeah,
makes
I just
sense.
cancelled x square. Here you have two x's, and in the bottom you have three x's, so two x's will get cancelled. Okay, so this is the derivative of this, 3 over x. So now you can find out this answer. So derivative of ln x cube we got 3 over x times, right?
So that's just the first half. So now I need to do
Cosine
3 over
x,
x times negative sine x.
yes, plus ln x cube, just write it as it is. And derivative of cosine x is
A negative sine x.
negative sine x. So times negative sine x. And you can further simplify this. So this becomes 3 cosine x over x minus, because this negative sign I'm bringing this negative sign outside, so this becomes minus ln x cube times sine x. This will be your final answer.